Sorry. If you told me ahead of time, I would have made sure I was here. But crap happens. Yeah. Probably a good idea before a quiz, right? Come on down, see me. I'll try to make sure I'm here on Thursdays. That way, if people want to pop in, they can. Yeah, that's cool. Yeah. All right, so here we are. Okay. How do you solve a problem like Maria? Well, we got to get D on its own. So how do we undo division? Multiplication, right? So we multiply by 8 to both sides. Negative 8. Now, I'm going to do something, say nothing. Ta-da! Now, check it. Give me a number that's greater than negative 8. How about 0? Great idea. So 0. Is 0 divided by negative 8? What's that?
0.
Just 0. Is 0 greater than 1?
Yeah. No.
No. Do you see how that's goofed? Why is that goofed? Why does that give me something different? Because this says that it should always be greater than 1, and now I've got this, which should just be the same thing, just a different way of looking at it, but it gives me something that doesn't work.
Wait.
Why is it goofed? I didn't flip the sign, right? When we divide by a negative or multiply by a negative, we have to flip the sign. Now check it. Give me a number that's smaller than negative 8. Negative 9, great idea. Negative 9 divided by negative 8. Well, it's going to be positive, right? 9 over 8, is that bigger than 1?
Yes.
Yeah, 9/8. 9/8,
Yeah.
right? 9 over 8. So that checks out. Pick a number that's maybe easier, right? Give me a number that's smaller than negative 8. How about negative 16, right? Negative 16 over negative 8, that's positive 2. It's bigger than 1, right? I don't know.
Wait, that's confusing.
What I did is I checked my answer, right? This is my answer. So I'm picking a number that's less than negative 8. How about negative 16? Negative 16 divided by negative 8 is positive 2. 2 is bigger than 1, right? Yes, sir. Change the sign. So if we didn't, it would give us a false statement, right? That said before that D is greater than negative 8, right? Now, let's pick a number that's greater than negative 8. Well, how about 0? 0 is bigger than negative 8, right? So if I plug that in up here in the original problem, I get 0 over negative 8, which is just 0. Is 0 greater than 1? No, so it gives us a false statement, right? Now, if we start out with something true and we obey our rules, we should still have a true statement when we're done, right? We're not changing the problem, right? It's not like, oh, I don't like that one, I'm going to change it, right? No, we're just looking at it a different way. And so we changed the problem when we forgot to flip the sign, actually. So the rule is, to make sure you don't do that, is that whenever we divide or multiply by a negative, only divide or multiply by a negative, we have to flip the sign. Because when we flip it, it makes it true again. So this right here is good. We need to write our set notation. D can be any number, so you can write it one of two ways. You can either write like this, exists in the real numbers, right? Big bar, negative 8 greater than D. Or you could write it like this. Because D can be any number, we can do this for shorthand. Like that. Now, if D can't be any number, like any real number, then we have to specify, right? Maybe it's only natural numbers. You can't just write that. Yeah.
So if we flip the negative 8 to D.
Yeah, another way you could have written it would be like this. D is less than negative 8. Right? It says D is less than negative 8 there, so it should say less than negative 8 here. I like to keep my smaller numbers on the left and my bigger numbers on the right. And which number is bigger, the negative 8 or the D? Oh, what? Actually, you're right. This should be like that. Negative 8 is bigger than D, so it should be on the right side. Either way works. Either way works.
Like the first one or the second.
Any of these. Then we need to graph it, right? Which you totally remember to do. Remember, we graph on a number line because we only have one variable. So this says D is less than negative 8. So here's negative 8. Open or close circle? Open because it doesn't include negative 8, right? It has no line underneath. Okay. And now which way is less than? D is less than negative 8. It's over here, right? So D is somewhere over here. Again, we're going to negative infinity on this side, whereas this one's going to positive infinity, right? So any number between negative infinity and negative 8, non-inclusive for negative 8. Need to make a note for myself. another thing I want to show you guys next week. All right. How do you feel about that one? Better? The tricky part was the negative. Remember to flip the sign. Do we know how to write the set notation? That's intimidating, but it's not that bad. Yes, sir. Baker. No, it's cool. Any of these is fine. Oh, you forgot to flip it. Is that what you're saying?
Yeah.
Okay, that's cool. Do it now. As long as you know it. We're not turning this in. Even if we were, I don't care. As long as you know, it's all good. I want you to be ready for the quiz. Let's pick another one.
3B.
Really?
Yes.
2A.
I still confused on how to graph them.
That's okay.
Oh, those guys good?
2A. Nevea, what's the problem?
8 and then in parentheses.
Whoa.
Never mind. It's negative 8b plus negative 6. That's in, yeah, okay. B. And then there's the is greater than 10.
All right, so here we are. So first of all, I'm going to rewrite this to look a little bit nicer. Right? We cool with that? Plus a negative 6b is just negative 6b minus 6b. Okay, you with me? So our b's are together on the same side, so let's just put them together, right? Minus 8b minus 6b. How many minus b's is that? 14 b's. The bees! The bees! Now, we want to get b on its own, so what do we need to do? Divide both sides by negative 14, right? Divide everything, really, is how we should say that. So b is going to be less than, because I have to flip the sign, I'm dividing by a negative, right? 10 over 14 with a negative sign there, right? Yes, sir? I put the negative on the outside, that's what I do. The whole thing's negative, right? Yes, sir? Nope, let's simplify it. Both of those have a factor of 2 in them, right? So negative 5 over 7. That is ideal. So minus a half if you don't. Now, how do we feel about this portion? Pretty good? Pretty decent, at least? I'll take decent. Now let's get to the graphing. That's where things get weird. Okay? Flip the sign. That's the thing everybody's going to forget. It's the only thing you have to remember, honestly. Now we're going to do set notation. So set notation says on the left side, we say any restrictions on B. Is B restricted to any particular set?
No.
Is it only natural numbers? Is it only whole numbers? No. It can be anything. So if it can be anything, then I just do this. You could also put exists in the real numbers, right? Because real numbers are every number, right? But I'm going to do that. And then I'm going to write what I got. That's it. So what does this tell us? Why is this different? Okay? And it seems silly now, and it is. It will be less silly when we have more variables, more restrictions, etc. Okay? I just want you to get in the habit now. So this tells us B can be any number as long as B is less than negative 5/7. That's it. Now maybe we say B can be any natural number as long as it's less than negative 5/7. Maybe that's a different problem, right? And natural numbers are just your counting numbers, right? So it couldn't be like negative 4.5, right? That wouldn't be allowed. Here it is, because it's any B, right? But other problems might have further restrictions on the left side here, Nevea, right? But this one doesn't, okay? So now we're here. So that's done. Let's get the graph. So what we do is we pick the number, negative 5/7. Dear Lord, don't try to count that out and figure out where it is, right? Open or close circle? Open, right? It does not include negative 5/7. It cannot equal negative 5/7. Does that make sense? Okay. If it had a line under there, then I'd color that in, because the color is where it is, right? Now, where is B? It's less than negative 5/7. Where is less than? To the left. So I would color in the left side, because again, the color is where B can be. Notice the color stops there. Okay. How do you feel about that now? A little bit better? Better? Okay, I'll take better. Thank you for saying that, Nevea. I appreciate it. Not the better. I mean, obviously I appreciate that, but telling me that you're struggling with the graphing. Feeling a little bit better now?
Yeah.
No? How can I help? All right, so here's how we do this. So, first off, do you agree with me up to there?
Yeah.
How about now?
Yeah.
How about now?
I didn't do it.
How about now?
Yeah.
Okay, so we're good in the first half.
Yeah.
All right, this.
I get confused on that.
Okay, so here's the deal. See how this is the same dumb crap as that?
Yeah.
That's all that ever is.
But then, like.
On the left side
Yeah.
of the big bar, just tells you what kind of number B is allowed to be. Now, B in this one, it's not a word problem, so it could just be any number, right? So it's just B. You could also write it as B exists in the real numbers, because real numbers are every number, okay?
So, like, how you have the.
Yeah, like on this one,
in front of it?
right? How I did for D,
Yeah.
right? I could do that. Or the shorthand for that is just regular D, okay? Some problems you're only allowed to have natural numbers for, right? If I'm saying I have less than 10 sheep, right? Less than 10 could be any number, right? It could be like 9.5. But we know it can't be that because sheep only come in whole sheeps, right? So we'd say any number less than 10. Also, here, if that stands for sheep, okay, it would have to be a natural number. So I would write something like B exists in the natural numbers. Sorry, here's my N. That's what I would write, but not for this one. Baker.
I did everything that you did except the that.
Okay, so that's the last thing you need to do. Do you understand how to do it?
Opposite side.
You what?
I did the opposite side.
You colored this side?
Yeah.
Okay, so this says B has to be less than. Did you remember to flip your sign?
Oh,
That's it, right? That's the killer. You forget to flip the sign, it's gonna screw you over all the way down, right? Cool. It's all right. That's why we want to catch these mistakes now. Isaiah,
Can you go over 1B?
1B for the next one?
Yeah.
Yeah, we can do that. Isaiah, tell me what 1B looks like.
G minus 11
Okay, A times the quantity of G minus 11.
is greater than or equal to 2.
Check out.
Yes.
That what we got? Okay, cool. So a couple ways to do this. One, that's 8 times something, right? So we can divide by 8. You want to do that? Right, it's 8 times something. Let's divide everything by 8. So we get G minus 11 in here. Oh man, what's 2 divided by 8? A quarter, right? Do we need those parentheses now?
No.
No. That's one way to do it. The other way to do it is distribute the 8 first, so you get an 8G minus 88. Right? Then we add the 88 over, we get 90, and then we divide by 8. Okay? I'm going to keep doing it this way. Now we have G minus 11 greater than a quarter. And I'm going to add 11 to both sides. And when I do that, I get this. A quarter plus 11. Now, I can add those together. Let's think about this. How many quarters, because that's what this guy's talking about, right? We got to get this apples to apples, commi to nomis. How many quarters in the number 1? 4 quarters. Always start out asking yourself that question, because you should be able to get that right. Okay? If you jump to 11, it's going to be hard. How many quarters are in the number 2? 8. How many quarters in the number 3? Are you seeing the pattern here? 12, right? So if we have the number 3, there are 12 quarters. So 3 times 4 is how we got that, right? Well, if we have the number 11, how many quarters are going to be? Not 33. How many quarters? 44. Check it out. I'm going to write it. A quarter plus 44 quarters. Now, check it out. Division and fractions are the same thing. Is 44 divided by 4 11? So we didn't change the problem. We just looked at it a different way. Okay? That's all. We're just looking at it a different way. How many quarters is that? Well, it's going to be 44 quarters because 44 divided by 4 is 11. Now, that means G is greater than or equal to 45 quarters. Yeah,
What if we multiplied and you got the same answer?
it's all good.
Alright.
Yeah.
Would you accept 11.25?
Yeah, that's what I.
I'd prefer not to have that, but I will accept it. It's an exact decimal. It's an exact decimal, but you're not going to have calculators in the quiz. Okay? You're just not. Yeah.
98 is equal to.
Yeah, so that is the same thing as 90 over 8, but it's just not simplified, right? Divide by 2 to both, you get 45 over 4. Okay? Again, think about how many quarters are in the number 11. 4 and 1, 2 and 8, 12 and 3, 16, 20, 24, 28, 32, 36, 40, 44. If you got it. That's 1B. Give me another. Oh, wait, hold on. We got a graph. Set notation and graph, real quick. Set notation, G can be any number, right? And it has to be greater than or equal to 45 over 4. Here's 45 over 4 on a number line. Open or closed? Closed. Greater than, which side, right or left? To the right, to the right, to the right. That's where G lives. Anywhere over there. How you like them apples? Good. Then they must be pink ladies, because that is like the only good apple. They are, kind of.
Wanna, like, Granny Smith?
They're okay. Granny Smith's okay. Red delicious? Lies! Neither red nor delicious. It's more like a maroon, chartreuse, burgundy, pinot. I don't know what color this is, but that's more like a red delicious color right there. And it's not delicious either. Red delicious are disgusting. They're always so mushy.
Are they the red apple?
Yeah, the big red ones, right? It's a lie. It's a marketing campaign. It's like world's finest chocolate, right? That's a brand name. It's not actually that good. Somebody was growing really crappy apples, and you're like, you know what? I know how we can sell these. We'll call them Red Delicious. And now they're everywhere.
So we can save all these good apples.
Give me another one. 3C. Mitchell, read 3C to me.
Negative 12 plus, in parentheses, negative 11 is greater than or equal to negative 6, and in parentheses, W plus 2.
All right, check it out. A couple ways to do this. First off, like, that's ridiculous. How about we just put that together, right? That's negative 12 minus 11. That's going to be negative 23. Like, good God. Who makes these things? All right. This one, actually, I didn't.
Is that why it's a website?
It's because it's freaking garbage. Yeah, I know. I'm sorry. I've had to deal with computer issues lately, and it's making me mad. All right, so now we're here. Now, remember, last time we divided by this, and that worked. You want to do that now? Yeah, sure, why not, right? If you distribute it, you're going to end up dividing by negative 6 anyway, because we're going to have a negative 6w, right? So let's do that. Let's divide by negative 6, and we get a positive answer, right? Because negative and negative is a positive. So it's 23 over 6. That's as simple as it gets. And we have to flip the sign because we divided by a negative. You smell what I'm stepping in?
Yes.
Now we're going to subtract 3. So I'm going to write that. Don't need to flip the sign. We just subtracted. Now, how many sixths are in a 3? Again, break it down. How many sixths are in the number 1? 6 sixths. How many sixths are in the number 2? 12 sixths. So how many sixths are in the number 3? 18 sixths. So that's really this. And again, check it. 18 divided by 6, is that 3?
Yes.
Then you didn't change the problem. You just rewrote it in a different way. So I've got 23 sixths. You've got, and we're going to take 18 of those away. How many sixths do I have left? 5. Set notation. W can be anything. I'm going to write it fancy with the R. You could write it without it. And I know that 5 sixths is less than or equal to W. Here's my number line. 5 sixths. Open or closed? Closed. Line underneath. W is greater than that over here. All right, Baker. I heard you got something different. 3C.
Yeah.
All right, that was the problem, right?
Did I get maybe 26?
Watch up here. Eyes up here. Baker. Was that the problem? This right here, is that the problem? Okay. I know what you mean. Are we good up to here?
Yeah.
What about now?
Um,
Here's what happened. I divided by negative 6 to both sides. Now, did you distribute, Baker?
I did. Yeah.
So you did negative 6W minus 18? That's cool.
Yeah.
So you had this. Okay? So that's what you had. Did you add the 18 next?
Where did I think you get 8?
The negative 6 has to go to the W and the 3. That's why it's in parentheses. Distributed property. That's where you made the mistake, right? So you were good up to here.
I distributed, but
You should have got negative
I
6w.
never write it down.
Ah, there you go, buddy. Write it down. You dingus. Write it down. Shion,
Oh, it's about that other problem.
which problem? This one?
Last one, yeah. I did W is greater than 5, 6, so like my sign isn't flipped.
So you had this.
Yeah.
That's fine. Right? You can read it right to left or left to right. Doesn't matter. W is greater than or equal to 5, 6, or 5, 6 is less than W. Right? Good question.
Wait, I didn't know if you're supposed to flip the sign.
You're only supposed to flip the sign if you divide or multiply by a negative. Okay? Here, that didn't flip the sign. She flipped the whole thing. Do you see this? The whole thing got flipped. That's just a different way of writing it. Right? 2 plus 3 equals 5. 5 also equals 2 plus 3. Right? That's no big deal. When we say flip the sign, we mean keep everything else the same except the sign. Like when we divided by negative 3 here. Or, right? Or by negative 6. See how this was the same on both sides, but the sign flipped? You have to do that whenever you multiply or divide by a negative. Yeah.
For the graph, where did it go the other direction?
W is greater than 5, 6.
Yeah, but where did it go in the other direction than the sign?
If it was written like this.
Like the one down below. Yeah, that one. Where did the
5, 6 is smaller than W. Here's 5, 6. W is on the right because it's bigger.
Where did that go in the other direction?
Nope. Read it from the variable. W is greater than 5, 6.
Oh,
Right? Now read it from the letter, or the numbers. 5, 6 is less than W. Well, if a number is less than another number, doesn't that number end up on the left side?
yeah.
Right? So this guy is less than W. So W should be to the right of this guy. This guy should be to the left of W. Same way of saying it. Good question. Next. Any more on this one? Ethan.
Well, go to 4B.
4B. Give it to me.
I'll get it up.
Yeah, go.
No, like what everybody else.
Baker, out of all the people to say that in here, come on, man.
Alright, so 8 times -3 and the -3 is
Yep. Shh.
greater than 6.
Doesn't see the X plus 9.
Thanks, Logan.
6 times the quantity of x plus 9. All right, so here's what we're going to do. First of all, thanks, problem makers, for giving us this extra step to do. What's 8 times -3? It's going to be negative something. 24. I always have to do 8 times 8 is 16 and add 8 in my head. I don't know why. All right, Jace, what's your question? Yeah, go. All right, next step. We can either divide by 6 or distribute 6. What do you want to do? We've been dividing by 6 so far. You want to distribute?
No.
Yes.
Yeah, okay, we'll distribute.
I just make it.
Sorry, guys.
It's an extra step, but it's okay. Sometimes people like that. So what we get when we do that is negative 24 greater than 6x. What's 6 times 9? 54. Do you see how that's a little bit extra, right? You could have just divided by 6 and got negative 4 over here. This one's actually kind of nice. But it's okay. So now what are we going to do? Well, let's get the prenup, move the the 54 over by subtracting. We get negative 78. Now we divide by 6.
It's not a nice number.
Oh, it actually is, because 60 goes in nice. 18 more than 60 would be. Ta-da! Now, what if we didn't do that? No, it's cool. No, that's cool. I'm glad I wanted to do that. That's why I asked it. I never ask a question I don't know the answer to. All right, so here we are.
Hold on, what's the point of asking questions?
To get you guys to think.
Oh, how do you get
All right.
That's just easy.
13? Where you come from?
I'll show. Did you do it this way, Baker? Did you distribute?
Yeah, but I did, I got negative 78
Uh-huh.
Did you divide by 6?
divided by 6.
Yep, and that actually comes out nicely to 13. Yep. All right, so what if we didn't distribute? What if instead we just divided by 6? So forget that. If we divide by 6, negative 24 becomes negative 4, right? And we get x plus 9 on this side. Cool. Sometimes it's better not to. The last two that we did, it probably would be better to distribute. This one is just, it works out nicely. So I'm going to subtract 9 now. I didn't have to flip the sign, right? I divided by 6, which is a positive number. won't do it. Subtract 9, we get negative 13. So now, set notation. X can be any number, so I'm just going to do that. And then I know that negative 13 is greater than x. I would probably flip the whole thing there and write it like this. Again, flipping the whole thing is different than flipping the sign. Those are the same thing, right? The exact same thing. I just read it from left to right instead of right to left. Okay? Changing the sign actually changes the problem. But we want to do that when we divide by a negative. We did not divide by a negative, so we didn't have to flip anything. Either of those would work, though. Okay? Now, when we graph this, it's going to look like this. Yeah, I know. Isn't that cool looking? So we have negative 13. I'm looking at this one now. Okay? Stick with that. Open circle. Yeah. And then x, I always read from the variable. X is less than negative 13. Well, here's negative 13. Which side is less than, left or right? Left. To the left. So x is over here. Again, pro tip, always read from the variable, Baker. So instead of reading negative 13 greater than x, always read from the variable. Go x less than negative 13. Okay? Always read from the variable. Always read from the variable. It'll help you. Okay? The number I'm thinking of is less than negative 13. Is a lot easier than negative 13 is greater than the number I'm thinking of.
Well, how do you know what number?
Right? You see what I'm saying? Right? Well, that's what x means, right? It's a mystery number. So the number I'm thinking of is less than negative 13. Oh, okay. That's not too bad, right? Like negative 16 would be an answer. But if I say negative 13 is greater than the number I'm thinking of, you're going to go, what?
I get it.
Right? I like it better from the variable out. All right, let's pause on that. I've got you a little review packet for the quiz tomorrow. Super small quiz tomorrow. All it is over this stuff. And if you struggle with those, that's okay because these are actually a little bit easier. I think the distribution is the thing that was kicking most of you guys. Yep, that's it. She ain't thick and she doesn't have a lot of time. She wins the
And then go in for the left and then get over here and then retake the test. And get a grade on the retake. And then you get a A plus and then you get a 4. No?
I didn't see what it was. I didn't read it yet. So my school group said, can I take the quiz Monday?
Bomberman?
Download the new Super Mario Kart game.
All right, let's review. Solve and graph each inequality. Be sure to represent your answer as a solution set and be sure that the set makes sense given the problem. Here's the fun thing. I told you I've been having computer issues, right? I was supposed to have more on here, and they're all word problems, but they're gone. You're welcome. Which means they will be on next quiz, which means next quiz will be even bigger, and next week we have a shortened week because it's homecoming. So you win some, you lose some, right? All right, so we don't have to worry about set notation being difficult, right? All real numbers for all these guys. So here's the deal. Taking this guy, what do you want to do first? Add 14, so we get 5x greater than 20. Now what? Divide by 5. Do we have to flip the sign? No, because we didn't divide by a negative. X greater than 4. So when I write my set notation, x, line, x greater than 4. And then I graph. Here's 4. Open circle. X is bigger. How you feel about that?
Might not fail this test.
Good answer.
Number 2.
Wait, what the?
Wow, you need to watch it. Yeah.
Ethan!
How do you know if it's be an open circle?
Great question. So notice x, I got it. X is greater than 4, but it can't be equal to 4, right? So remember, the colored area is where x could be. X can't be 4, right? So I have to keep it open. Now, if I had a line underneath here, Ethan, then it could be equal to 4, right? So that's non-inclusive, right?
So that's when you close.
Yeah, uh-huh. So this says x greater than 4, non-inclusive, right? Any number greater than 4, not including 4. Yeah.
Will you mark us off if we don't fill in the circle?
Yes.
That's even?
That's how you do the graph. All right. Negative 3x is less than or equal to 9. There we go. There's some zoom.
Might as well start right now.
So what are we going to do to get x on its own?
Divide negative 3.
Divide by negative 3. Do I flip the sign?
Yes.
Yes, I do, because I divided by a negative and I get this. So set notation real quick. Watch this. Did it.
Whoa.
Crazy. I got extra space over here, so I'm going to be even crazier. I'm just going to write all real numbers. Nice. Redundant, but it gets the job done. Now I'm going to giraffe it. Here's -3. Open or close circle? Close. Very good. So close it. X is greater than or equal to -3. So which side's greater than, right or left?
Right.
So X exists over here.
Correct.
Number 3, and the party's over, right?
No, I like part.
All right. What do we do first?
Minus the
I would get rid of the -4, right? Before we start multiplying and dividing, let's get the prenup.
15.
So we're going to subtract 4. We get 15 here, yeah? Now check it out. I can either multiply by 2 to undo the division, right? I could also divide by 5. Do you see how that's a 5 in the top there? The top means multiplication, right? So let's cancel the 5 and be crazy. Let's divide by 5. What's 5 divided by 5 here? 1. What's 15 divided by 5? 3. Do you see how that works? Right? The top means multiplication. The bottom means division. So if I want to get rid of the 5, I have to divide. Well, okay.
That's crazy.
Did it? Yeah. Why has no one taught you fractions this way? This is so unbelievably mind-boggling to me. I don't understand. Like, you spend how many years doing fractions in elementary and middle school? Like, and they couldn't bother to be like, hey, the top means multiplication, the bottom means division. Yeah.
So would
They just
times by 2.
Yeah, so now we're going to times by 2, and we get this. Did we have to ever flip the sign? No, we never divided or multiplied by a negative, so we're good. So set notation, bam, there it is. Again, being fancy, swag points. There's 6. Open or closed, Ethan? Open. Less than, which side? Left. Double check your signs tomorrow to make sure you're reading them correctly, okay? Because that's going to be a silly thing to get wrong, is to write that correctly and then color the wrong side. Again, read from the variable out. Yeah, I know. All right, number 4. Let's add the 4 first, and we get 16. Now, you want to multiply by 3 or divide by -2 first? Do you see what I'm saying here? Right, the bottom part is divide by 3. So we have to times by 3 to cancel it. That's going to make a big number. I'd rather not. Now the top means multiplication, right? So if it's -2 times x, right, with some other stuff going on, right? If it's -2 times x, what would you do to get rid of the -2 times x? You divide by -2, right? That's going to get us a smaller number. I like small numbers. So what that gets us is a third x, and I divided by -2, right? So I'm going to flip that sign, and I get -8.
wow.
Right? It's just another way to think of it. Right? Why get 3 times 16 and have to bust your brain?
That's
Right? I'd rather not. And now we're going to times by 3, right? Multiply by the reciprocal. And so what we get is x greater than or equal to 8 times 3. Again, I have to do it in my head. 8 times 2 is 16. Add 8 more, it's 24. That's negative. And again, we had to flip the sign earlier, so we're good. Right? We divided by a negative. We flipped the sign. We're good. Here's x is -24. Open or closed? Closed circle. X is greater than. That's to the right. Go back and watch this video if you're confused. Seriously. Pause, rewind. There's some people in here that are really feeling like they're getting it. Talk to them. Okay? Hit them up on the Snapchat.
What up, player?
What up? You got the answer to number 4? All right, number 5. She got more problems, right? We got lots of things we got to move. What do you want to move? The x's or the regular numbers first? X. All right, x it is. So let's subtract 3x from both sides. Do I have to flip the sign? No. Nope. Subtraction or addition, you never have to flip. It's only when you multiply or divide by a what? A negative. Very good. So we get this when we subtract 3x. Now let's move over the regular 7. We subtract it. Do we have to flip? No, we only flip when we multiply or divide by a negative. So I subtracted the 7. Now to separate the x from 2. Remember, separation is division. Division is divorce, right? I divide by 2. Ta-da! Here's my notation. Good Lord, use the electric one in the back. What year is it?
2019.
Now when I graph this, we put the 2 down, close circle. Like it's about the same loudness, but it's way faster, right? So close circle and read from the variable, okay? Here's x less than or equal to 2. So less than's to the left. Ta-da!
Wall magic.
Yeah. Yeah. Number 6, and then we're done.
Yay.
Are you okay for real? Okay, got you. You're mocking everybody else. Man after my own heart. All right, number 6. Oh no, there it is. What do you want to do first? Move the x's or move the regular numbers? X's. Okay. So what do you want to move? The negative 13 over or the 4 over? Okay, we're going to add the negative 13 over. Good idea, because if we move the 4, it would be negative here, and we'd have to divide by a negative, and we might forget to flip our sign later. Could you do it? Yeah, there's no rules. Okay. But I'm going to add the 13x, and we're going to get 17x on this side plus 6, less than negative 23. And now I'm going to get my regular numbers together, my constants, right? So I subtract that 6. You smell what I'm stepping in? And I get negative 29. Baker, you having trouble? All right, so check it out, my dude. To get from there to there, I added 13x to both sides. Baker, you watching? Because there's a negative 13x there, I'm moving it over. I'm moving it. You see it? Yeah, buddy. Just with these signs instead of equal signs. And the only difference that we have to worry about is when we divide or multiply by a negative, we have to flip the sign. Otherwise, it's just like equations. Right? So now, I need to divide by 17, right, to separate it from the x. Separation is division. Division is divorce. So x is going to be less than negative 29 over 17. When I divided by 17, did I divide by a positive or a negative 17? A positive. So do I need to flip the sign? No. Again, that's gross looking, but who cares? We're done. There's the answer. Now let's graph it. Oh no, where's negative 29 over 17 on the number line? It's right here. Because I said so. Open or close circle? Open. All day. Open. Read from the variable. X is less than that. Well, which side is less than?
Left.
Every time. Less than is to the left.
I draw the stupid notation.
Oh, the squiggles?
Yeah, it's literally like a line.
Yeah, my right ones are better than my lefts, I think. You what? Everyone shut up so I can hear him.
Are you adding like stuff in the other test like you did?
Go in the dark.
No, quizzes are never, so guys, quizzes are never cumulative. They're whatever we did that week, right? Tests, by their nature, are cumulative, right? It's what we did in that chapter, or however you want to define it, right? Last couple of weeks. So we never have a test without having quizzes under our belts. So we're going to have a quiz this week, we're going to have a quiz next week, and then we'll probably have a test soon after that, okay? Usually it's 2 or 3 quizzes per test, right? I don't want to go too much further because then your test gets gigantic.
No one likes a big test.
Yeah, right? Yeah, why do that?
Even the teachers don't like it.
Because then I have to cut more stuff, and then I have to cut stuff that's actually good, right? To make it actually fittable in 45 minutes. Yeah.
To retake the test, do we have to like be in here?
What you need to do, okay?
I have all the things.
You have all the things done?
I don't know.
The review guide, the homework? Well, that's what you need, okay? The review, that thing's adorable. That's the absolute last step is filling that out, okay? What you do is when you're done retaking it, like literally, when you have finished your retake, you staple that to the top. That's the last step, okay? What you need to do in the meantime is get your review guide done from that week. If you need another one, I'll give it to you, okay? And the homework for that week needs to all be turned in. You're fine on that, okay? So if you need a review guide for that quiz or whatever you're trying to make up,
Grade every quiz.
so come see me.
No, I think that I have some.
Okay, whatever ones you don't have, I'll print you. Just come see me, and then when you get those done, we're good. Now, what I would do is, if I were you, I would come in and get help for the review guides, which will also help you get ready for the retake. Right? Because I'm guessing you can't just do the review guide on your own. Right? Well, that's typical, right? That's why you did poorly on the quiz. That's not unusual. Yeah.
Since we're going to be going tomorrow, can I take the quiz on Monday during homeroom?
Can you finish it within that time limit? Yeah, probably. Yeah, we'll do that.
So then, when we retake our test, when I get that far, like, when do you retake it?
So what'll happen is when you have the review guide done, I'll take a look at it, okay? And I'll give you a couple of problems that are similar to that. So you'll come in at some point during homeroom, before or after school. We'll do a couple problems on the board. You'll sit there and do them, right? I'll just make them up off the top of my head.
Okay.
And if you nail them, then I know you're going to pass the test and not waste my ink, right? And then I'll say, okay, now that we've done this, when would you like to take the test? Can't be the same day. I don't review and retake the same day because that's regurgitation. And you pick the day and you do it. Okay?
Well,
Can't be in class. Has to be outside.
what if you're busy before and after school every day?
That makes things really difficult.
I have swimming at
Try to swim into or try to squeeze in homeroom. You don't practice on Fridays.
after school.
Yeah. Yeah. So there's an option. Like, I don't care.
Or Thursday.
Like you could be a student and be like, I literally am like dead between the hours of 3 o'clock to 8 o'clock the next day. Like I don't exist. And I'd be like, wow, that sucks. How can I help? And if I can't, then you know what I mean? Like, I don't know. You tell me what works for you. Right? Like, I get it, but like, okay, then what? Like, I don't know how to help you, right?
Can I stay
I
right
have
now
one
to get
down.
all my review guide?
You can